In this video, I'm going to talk about correlational research in psychology. Now, I'm making this video for an introductory psychology class, and so not for a statistics class, not for a research methods class. So I'm going to try to keep it as simple as possible. Now, correlational research is not defined by the specific methods of the study so much as it is defined by the statistics used to analyze the data. All right, so you make your observations, you make your measurements, and you have to use statistics, math, to figure out if you got significant results. If you don't know what a lot of these terms means, it's okay. If you're a psychology major, you will learn more as you go along. All right, but let's talk about some basic terms. Anytime you're conducting a study, what we call a quantitative study, quantitative means it involves numbers, so you're going to be applying statistics. If you're curious, the other type of study is a qualitative study where it's verbal, it's descriptive, it's not based on statistics. Previously, I talked about observations and surveys. Some observational research gives you measurements that can be analyzed with correlations. Some surveys and interviews give you measurements that can be analyzed with correlations. So, you know, it's good to point out that sometimes there's an overlap with some of the techniques that I talk about with research methods. All right, when you're doing a quantitative study, you should have variables that you're studying. A variable is anything that can change and therefore it can be measured. The opposite of a variable is a constant. A constant doesn't change. A variable changes. Anything that can be changed. So this can be something like your blood serum level of some hormone. It could be your score on a depression inventory. It could be the number of times a toddler says no during a toy cleanup task with their parent. These are all variables. They can be quantified. They can be measured based on observations. All right. A very simple example of quantitative research is you've got two variables that you want to connect in some way. You want to show that they're linked, that they're related. All right. If two variables are related, that means they are correlated, right? So correlational research is trying to show that two variables, you can have more than two, but we're going to use the simple example where there's just two variables, where two variables are correlated. Correlated means they're related. What do you mean related? They're linked in some way. They go up or down, decrease or increase in a predictable manner, a predictable pattern. Another term you might hear, they co-vary in a predictable manner. So what does co-vary mean? They vary. They vary, they change in a predictable way. All right. So it's okay if this goes over your head a little bit, right? Because psych majors, you're going to have more about this. Correlated means they're related. They're related. They are associated. They are linked in some way. Now, a very important thing to remember. If two variables are related, it does not mean they're related because one causes the other. A very common saying, correlation does not equal causation. Right? If you're a psych major, memorize that now. That comes up a lot. Correlation does not equal causation. A correlational finding, a correlational result, means that two variables are related, but we don't know why they are related. All right. The numbers you get for a correlation, there is a result called a correlational coefficient. Right? A correlational coefficient is the result that you get. If you take statistics, you'll learn how to compute a correlational coefficient. And that correlational coefficient has either a positive or negative sign. All right, so if we say positive relationship, that means the correlational coefficient has a positive sign. If we say a negative correlation, that means that that correlation coefficient has a negative sign. Now, correlation coefficients are limited so that they can only be between +1 and -1. All right, so you can't have a correlation coefficient of like 2.3. All right, it has to be between +1 and -1. The closer a correlation coefficient is to 0, the weaker the correlation. The closer the correlation coefficient is to 1 or -1, the stronger the correlation. All right, and if you've got a positive or negative sign, it tells you something called the direction of the relationship. All right, a positive relationship, a correlation coefficient with a positive sign. Positive relationship means that they both variables increase or decrease in a predictable manner. They both increase or decrease essentially at the same time. All right, to give you an example. All right, so something that is positively correlated. What if we find out that number of hours spent studying for the exam is positively correlated with your grade on the exam? That means the more you study, the higher your grade. They both increase together. Another way to think of it is they can both decrease together, all right? The less you study, the lower your grade. So they both increase, both decrease. All right, so positive relationship means they go in the same direction. When one is high, the other is high. When one is low, the other is low. Does this mean that studying made your grade higher? Nope, nope, nope. We can't determine that with the correlation. We just know that one tends to be higher. All right, we know that there's a pattern in the data. There's a pattern in the results. And so we can say they're related. They're associated. A negative correlation means that they go in opposite directions. One increases, the other decreases. When one is high, the other one tends to be low. So let's see, what is something that could be negatively correlated with your grade on the test? Maybe the number of hours spent at a football game the night before or something like that. All right, maybe you find that people who spent more hours, or just out in general, more hours out the night before the exam, the lower your grade on the exam. One was high, the other's low. That would be a negative correlation. All right, so negative doesn't necessarily mean like it has a negative impact, like undesirable, unwanted. It just means that numerically there's a negative sign, and it means that the two variables are going in opposite directions. All right, so for this class, that's what you need to know about correlational coefficients. Just basically be familiar. What does it mean to be positive versus negative? Know that correlation does not equal causation. And let me just check my book and my notes here to make sure I did not leave. Okay, I knew I forgot something. All right, one problem with correlations, specifically with people wanting to interpret correlations as evidence for causation. It's so tempting. They're correlated. It's because one causes the other, right? All right, there are some specific reasons why we can't infer causality from a correlational result. One huge problem is something we call the third variable problem. There may be some third unmeasured variable that actually explains the relationship between two variables. Kind of your classic example that many people get exposed to at some point during college is the fact that ice cream sales are correlated with violent crime. You want to know the direction? Hopefully you were like, oh, what direction? The more ice cream sales, the more violent crime. It's a positive relationship. And so some people are like, oh my gosh, does ice cream make people violent? Do you think ice cream makes people violent? All right, we definitely can't say that. And the problem is there's a third variable that can explain this relationship. If we were in an in-person class, I'd say, who can guess the third variable? All right, since this is being recorded, I'll have to go ahead and give it to you. Heat. All right, summer. Ice cream is sold way more in the summer when it's hot. There is also more violent crime in the summer when people are off of school and it is hot and miserable outside. That variable, time of year, climate, weather, that can explain the link, the relationship between those two variables. It is not because there's a causal relationship. It is not because ice cream causes you to engage in violent crime. All right. Another issue is if two variables are related in a causal manner, correlational, the calculations we do to compute a correlation, they don't allow us to see the direction of causality, like which variable causes which variable. So that's an issue too. So in general, we can't establish causality from a correlational result. All we can say is that the two variables are related, but we don't know why. The only way that we can determine that two variables have a causal relationship is with a true experiment. Now you might be wondering, well, what is a true experiment? Next video will be about the experimental design.